I'm Anil Kumar sharing with you some characteristics of rational functions. We have a question here where we'll kind of identify domain, X-intercept, Y-intercept, horizontal asymptotes, holes, and vertical asymptotes for a few rational functions. So we'll work with these four rational functions. You can always pause the video, answer this question, and then look into my suggestions. So let's take up the very first one, which is for us f of x equal to x minus 2 over 2x minus 6. So I'm taking 2 common, and then we'll write this as x minus 3, right? The other functions are f of x equals to x over 2x square minus 18, f of x equals to x square plus x minus 6 divided by minus 4x square minus 16x minus 12, and f of x equals to 2 over x square plus 4. So the first step is to factor. So let me write down the steps as we move on. So what we do here first is factor. So once you factor, the equation reveals a lot of material. Now here, denominator cannot be 0, so you can straight away write that x is not equal to 3. Since that is going to make the denominator 0. So in the domain, I can write x belongs to real numbers, where x is not equal to 3. Perfect. So that's the first step. Now let us see how to find x-intercept. Now x-intercept is a point where the graph crosses x-axis. So at this point, y equals to 0. To get y equals to 0, what should I do? I should equate x minus 2 to 0, right? So for that, I will write x minus 2 equals to 0. So that gives you x is equal to 2, correct? So the y-intercept will be at 2, 0, correct? So we get our answer. Let me write it in a different ink. So for the x-intercept, we get the point which is 2, 0. That means numerator is 0. F of x is 0. Perfect. Now what is y-intercept? For getting y-intercept, you just substitute x equals to 0. So if I write x equals to 0 here, what do I get? So that means you have to find what is f of 0 equals to. When I substitute 0 here, I get minus 2 in the numerator, 0 minus, and here 0 when I do, I get minus 6 divided by minus 6, which is 1 over 3. So in this particular case, y-intercept will be x is 0 and y is 1/3. 1/3, correct. So it's 0 and y is 1/3. So if you look into this equation, if I put x 0, I get minus 2 over minus 6. Minus minus cancel, you get 1 over 3. Perfect. Horizontal asymptote. Now for a horizontal asymptote in this, we know the degrees are same, correct? So you can look into this. Degrees are same, so ratio of leading coefficients. So here, the horizontal will be, let me write in a different ink, which is, we're looking for this ratio, right? So basically this is 1 here and 2, so horizontal asymptote is y equals to half. So think like this, 1 and 2, right? So we are looking for this ratio for horizontal asymptote. So which is ratio of leading coefficients. So when we have degree same degree, we have leading coefficient ratio, right? Holes. Now here, since we have no common factor, so none. No common factors in numerator and denominator. So this discontinuity is basically because of vertical asymptote. So the vertical asymptote is x equals to 3. So vertical asymptote is x equals to 3. That is the discontinuity. So where denominator is 0. So how did we get it? By equating denominator to 0. So let me say from this, for vertical asymptote, we looked into this part. So we said 2x minus 6 equals to 0. X equals to 6 over 2, which is 3. So I hope the steps are clear, right? So the whole idea is to understand how to find all these parameters for any rational function. So now I'd like you to pause the video and identify all these characteristics for the other 3 functions. So I hope you have understood these steps to find all these characteristics for rational functions. Let's do it once again. So we are given now the function f of x equals to x over 2x squared minus 18. We have to write domain. That means what? That means the denominator cannot be 0, right? So that is what we'll begin with. So the first step should be, we'll write 2x squared minus 18 is not equal to 0. So that means 2x squared is not equal to 18. X squared is not equal to 18 divided by 2, which is 9. And that gives you answer that x is not equal to plus minus 3. Is that clear, right? So that is how you do the domain part. Equate denominator to 0. We can write down our solution here that x belongs to real numbers where x is not equal to plus minus 3. Now both these points plus minus 3 could lead to discontinuities, right? So that means there are discontinuities. Here we do not have a factor x plus 3 or x minus thing in the numerator, so we could straight away from here itself write that this discontinuity is a vertical asymptote whose equation is x equals to 3 or x equals to minus 3. Do you get the relation? So you'll find that when you work with rational functions, then domain is actually related with these two, vertical asymptote or holes. Right. So I hope that point is clear. Now let's look into the X-Intercept. So when I say X-Intercept, it really means that graph crossing x-axis. So we say f of x equals to 0. Now clearly f of x will be 0 only if the numerator is 0, right? So we are now looking into the numerator part at which says x equals to 0. Is that clear? Therefore, we get a coordinate point which is origin. Is that clear? So that becomes your X-intercept. Now let's talk about the vertical asymptote. So for vertical asymptote, now let's talk about Y-intercept. For Y-intercept, x is equal to 0. Substitute x equals to 0 in your equation and find what is f of 0. So when I substitute 0 here in the equation, I get what? I get 0 divided by 0 minus 18. 0 divided by anything is 0. So in this case, Y-intercept is also at origin. Correct? Horizontal asymptote. Now horizontal asymptote is a value where what happens if x is very, very large. Now if denominator degrees higher, in that case we get y equals to 0 as horizontal asymptote. Perfect. As far as the holes are concerned, there are none in this particular case since we do not have a common factor in numerator and denominator. Correct? So I hope the steps are absolutely clear. Now let's move on to the other two. Now here is the third example. We are given the function f of x equals to x squared plus x minus 6 divided by minus 4x squared minus 16x minus 12. First step is to factor. So product of minus 6, sum of plus 1. So that means 3 and 2, 3 with positive sign and 2 with negative. Denominator, we could take minus 4 common, and so we get x squared plus 4x plus 3. Now we could factor 3 and 1 will work. So we have x plus 3 times x minus 2 in the numerator, and denominator is minus 4 times x plus 3 times x plus 1. Now from here you see we have a common factor in numerator and denominator, which is x plus 1. Now this common factor leads to the whole, right? So whole is at x equal to minus 3. Correct? Now it is important to find this point itself. So we could actually write this function as, let me write here. So we have now f of x equal to x minus 2 over 4 times x plus 1, and this minus, let me write it here. Is it okay? Fine. Where x is not equal to what we cancelled is minus 3, what exists here is minus 1. So this minus 1 leads to vertical asymptote. So we could write this as x minus 1. Now for the whole, it is very important to give the point itself. So let's find the value. What is the value when this is minus 3? This is for whole, right? So if I substitute minus 3 here, I get minus of minus 3 minus 2 over 4 times minus 3 plus 1. Is it okay? So it is minus of minus 5 over, here it is minus 2 times 4 is minus 8. So that gives me minus 5 over 8. The whole actually is a point where the x value is minus 3 and the y value is minus 5 over 8. Is it clear? So that is how you get your whole. So it is important to find y also. That's what I'm trying to say. Okay. Now, domain clearly is taking care of both the restrictions. So for the domain, we can write x belongs to real numbers, where x is not equal to these 2 points, minus 3 and minus 1. X-Intercept. X-Intercept means we have to substitute that numerator to 0. Y will be 0 when the numerator is 0, right? So for X-Intercept, we have to equate numerator to 0. So that means x minus 2 equals to 0. That gives you x equals to 2. Now for Y-Intercept, you have to substitute x equals to 0 to get Y-Intercept. So in our equation, which is the simplified version, if I substitute x equals to 0, what do I get? Now this is the best equation to check. So what you get, these two terms will become 0, and it is this ratio. Correct? So for Y-Intercept, substituting x equals to 0, you get half, 6 over 12. So we get y equals to half. Let's write y equals to 6 over 12. Both negatives cancel, which is half. So the point here is 0 and half. Horizontal asymptote. Horizontal asymptote is basically the ratio of leading coefficients, which is right there. So the horizontal asymptote in this case will be y equals to minus 1 over 4. Is that clear? So that is how easily we can get all the parameters for the rational function. Here is the last example for us. It's a very typical example. 2 over x squared plus 4. Now here we have no restrictions. Do you see that? We have no restrictions. As the denominator, which is x squared plus 4, is always greater than, or it could be equal to 4. Correct? So it's never 0, right? So here the domain is x belongs to real numbers. X-Intercepts. So X-intercept is a point where the numerator is 0. Now numerator is 2, a constant, so it does not exist. So we can write none. Y-intercept. Now in this particular case, if I write x equals to 0, what do I get? So f of 0 is indeed equals to 2 over 0 plus 4, which is half. And therefore, the y-intercept here is 0 and half. Horizontal asymptote. Horizontal asymptote is the ratio of x. X is like x to the power of 0, right? So here, the horizontal asymptote is the x-axis, whose equation is y equals to 0. Holes, none. Vertical asymptote, none. So is that clear? So I hope with this you have understood how to find characteristics for rational functions. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that would be great. Thanks for watching and all the best.